This video is going to be about double displacement reactions and also precipitate reactions together. Precipitation reaction. Whoops, I don't have my pen. Okay. I'm going to spell this word very wrong. Okay. A precipitation reaction forms a solid product. And we'll see more of that later. And then a double displacement reaction is when is when oh my goodness. Okay. Two compounds exchange their cations and anions to form two new compounds. So kind of think about it, not with elements, it would be like, say you had AB plus XY, where this is A and X are both metals, B and Y are nonmetals, and what happens in these double displacement is A and X switch and B and Y switch. So you would have AY plus X. B, because remember, you still have to put the metal, the positive, first. And then you have to consider solubility rules to see if the reaction will occur. So this is when you get out your solubility chart rules, whatever you want to call it. And that's when you look. So I think, as we all know, the chart's set up that top half is things that are soluble, the bottom half is insoluble, and then it tells you what is the exceptions to that. And so when something is soluble, I don't think I spelled that right, that's okay, you'll denote it as AQ for aqueous, because soluble means it can dissolve in water, and that's what aqueous basically means, something dissolved in water. If it's insoluble, that's going to be solid, because it's going to remain a solid, and that's also going to be your precipitate, because a precipitate is that solid thing that falls out. So at least one precipitate is going to form. At least one precipitate will form for a reaction to occur. Because if it's all aqueous, all the ions will mix up, and nothing will happen. They'll all just still be dissolved. Okay, so I think, as we have all learned, writing these is quite time consuming, as you have to write 3 equations. So let's go over the 3 equations you're going to have to write. So we have the molecular equation. The molecular equation is just the complete formulas and the solubility info, which also known as the state of matter, which in most cases is going to be either aqueous or solid. And since you're doing double displacement, your reactants are probably going to be both aqueous, because they wouldn't combine to react if one of them was solid. So, always check, but most cases, probably both your reactants are aqueous. So molecular equations are just the type of equations you're used to balancing. You do need to balance them to work out. So once you get your molecular equation, you get it balanced, you get all your solubility info, you're going to go and write total ionic equations, or total ionic equation. And this shows the soluble aqueous part breaking into their ions. So this kind of shows what's happening within the reaction. It kind of shows that how the double displacement works, how we get the cations and anions to switch over. Something you need to take note when you're doing total ionic is spectator ions. And spectator ions are unchanged chemically from the reactants to the products. So they look the exact same on both sides. They're either going to be both aqueous, both solid. You're going to have the same amount, and they're going to look the same. And then once you get rid of all your spectator ions, you'll be left with the net ionic equation. And this is what, if you've done your Chapter 7 owls, this is what the owls wanted. They just wanted, without the spectator ions, they just wanted what was happening in it. So this eliminates spectators and the brackets and only shows the change, what's really happening, what changed in this reaction. And when you get this, it needs to be balanced. Balanced for both in terms of atoms and charges. So you just need to make sure your charges of your ions match up on both sides. So let's do an example, because these don't take 1.5 million years. You can tell how much I really enjoy doing these. So lead to chlorine, or chloride, reacts with lithium sulfate. Okay, so the first thing you want to do is you need to figure out what your products are, because these are both your reactants. That word reacts kind of tells you. These are both your reactants. It may help to write it out in word form, and so you just draw the little arrow like your equation, and now you know you're going to have lead sulfate plus lithium chloride. So this is how you're going to write it. This is going to be your first part of the reactants. This is your second reactant. This is going to be your first product and your second product. And this is how the double displacement. See, this is A, B, X, Y, and now we have A, Y, and X, B. Okay, so let's write the molecular. So you have lead to chloride. So that's where that subscript comes, because just like last chapter, you have to write the chloride because you need 2 chlorides, because it only has a charge of -1 to get the 2 pluses. And if you look on the solubility rules, you see that lead chloride is solid, and then it's going to react with lithium to sulfate, because again, 2 plus, 1 plus, or 2 minus, 1 plus, which is aqueous, and that is going to lead to lead sulfate plus lithium chloride, and lead sulfate is a solid and lithium chloride is aqueous. Okay, now we have to make sure they're charged. We have one, or balanced. We have one lead, we have 2 chlorine, chloride. We only have one chloride over here. So we're going to put a 2 here. And that helps because we needed 2 more lithiums. And now we're balanced. So now we can write the total ionic, which is going to take up a lot of room. So what you do is you only split these ones that have AQ on them. So P lead chloride is going to stay because it's a solid. So then what you're going to do is you're going to take this, you're going to write brackets because we're breaking this up, but it's together in the reactants, but now it's breaking up when we react it. So you take, if you have subscripts, you put them in front of your atom, and then you write it in its ionic state from the chart, and then everything's going to be aqueous in the brackets because it was aqueous, that's how it broke up. And then, so this is how you split up. You only split up the aqueous, and that's how it looks. So this is solid, so we leave this as solid. And then if you have a coefficient, not a subscript, but a coefficient, you can put it outside the brackets, because just like math, it'll distribute. And that is the total ionic. Let's see. That is the total ionic. So now we have to do the net, but we have to look for spectator ions. So those are going to be ones that look exactly the same both sides. So as we can see, these lithiums, it's just 2 plus lithium, 2 plus lithium. Here, they're the same. Nothing has changed with them, so you can cross those out. And also, that's it. Everything else is combining, doing something. So for our net ionic, would be PbCl2s plus SO4, 2 minus, copy it directly from the brackets, which produces lead sulfate, plus 2, make sure, don't forget that, chlorine. And as we see, we have a 2 minus charge here, we have 2 minus charge here, we still are 2, 2, we're all good and balanced, and that would be the total, or the net ionic for that. So one thing to note, I'll probably talk about it more in the acids and bases, is strong acids and bases are the only ones that are going to split apart. And then for the solubility rules, say you had something like, hold on a sec, so you had something like, let's say ammonium sulfide, that would actually be 2. Oh wait, that's an exception. So see, that would be aqueous because that's an exception. Let me think of a better example. I cannot think of one off of my head, but when you're doing the owls, sometimes, say you got something like CrO4NO3 2. So technically nitrate's not an exception, but since nitrate has no exceptions, this is still aqueous. Well, also these are both nonmetals. I don't know if that would happen. Okay, don't listen to me maybe, but just, look out for the solubility rules and take your time with those. I don't think this happens, so just maybe ignore that. But I think the rest of this video is correct. Please let me know if I make mistakes, so I'm not telling y'all factual stuff. I have my notes here, so yeah, this video is great. I really do hope these help. Please tell me to stop if I'm just annoying and these are terrible. But thank you so much. Let me know if you have any questions about this or need extra help practice. Anything else? Yes, thank you so much. So sorry. Bye, y'all.